I will try to explain that without doing mathematics. Again, a point which I discussed briefly yesterday, but let me say that in terms of some pictures. Suppose the planet is moving with the velocity v. This is the velocity of the planet. And let the spacecraft come with velocity larger than v and go around like this. If I see this, this is velocity u. If I see this, this is from the frame of the sun being at rest. This is the frame in which the sun is being at rest. If I see this from the frame of the planet, it will look like the velocity. Of course, this has to be more than v, because only then can it cross the planet, and it will look like it is approaching like this velocity. It looks like it will have the velocity v like this. Right? This will be u minus v. This is from the planet's frame. So it will go in this direction, and its velocity will be u minus v. That way. Right? Because it's in the planet frame, you do not expect it to change its speed, it will only change the direction. I have just taken as if it is a one-dimensional problem, and I have assumed it will move as u minus v. This is a very crude approximation to what we have done, but still the physics of it will come through. Okay. Now, this is in the sun's frame. Now let me go back to the sun's frame here. How do I do that? I have to add some velocity v in that direction. Right? When I add it, it will become, this is correct, I will have it correctly. This is u, this is u minus v, that is u minus v. So I add, it will have a velocity. Am I correct? U, it will have. So it has not gained any energy at all if I do it this way. On the other hand, let the planet come this way. Let this be the velocity with which it approaches here. What will be the velocity in the planet's frame? This is the sun's frame. In the planet's frame, this will be v plus u. Right? Here is my planet, and it is going around the planet, and it is coming with v plus u here. It's going around like that. It's coming like that. So now let me go back to the sun's frame. It will be 2 v. Okay. So in this way, it will pick up energy. And physically also it is clear. What is happening is, when it is approaching the sun, the Jupiter, it has to approach from behind and move back. The Jupiter will keep, this is the way it will look like from Jupiter, but actually its velocity is in that direction from the sun's point of view. Notice, from the sun's point of view, the thing was, it came with the velocity, actually I should write this velocity to be lower than v. It's coming with some v prime lower than lower than v, and this will be, what should I write? V prime plus v prime, sorry, u prime, and this will be. So it will be attracted in this direction, make it move, and that's why the speed of this will increase. This is yes. Which picture? 1, 2, or which one is the
second, third?
Okay, let's go with this. U is going this way. V is the planet's speed. This is as seen from the sun's frame. Let me go to the planet frame. In the planet frame, I have to subtract v from all these objects. So I subtract it, I get u minus v. Then in the planet frame, it is going around, its speed will not change, its only direction will change. Right?
Are we assuming that or what?
No, I am assuming that because energy of the thing when it comes out will remain the same. When it is far away, it's having some speed. Yesterday I had used omega I and omega I. And I said the magnitude of omega I is the same as magnitude of omega I. So I am now, here is my Jupiter. The path that I will draw to be that, but I am approximating this only to something like this. This will give you the essence of the physics of the problem. So what happens is, so v minus u is this way, and this will be the direct speed will not change. It will be in that direction. So I will have this as minus of this. So when I add this, it will become. I have to add. Let me go back to the sun's frame. In the sun's frame, this will just be minus u. Add minus u plus will be so much. Instead of u, it will be 2v minus u. That will be this. Am I correct? This is u minus v. That will be the speed. I hope I am right. Minus of that, so it will be minus u plus v. Now let me do it here. What will happen here? Let's go over the same thing. I come with v and I have u prime. U prime is less than v. Okay? And when I am looking at it from the planet's frame, it will look like u prime plus v. It is coming in this direction. Or is it? How should I write this? It should be u prime minus v. It will be u prime this way.
U prime minus v. V minus v prime.
V minus u prime. That way. So, and it will bend this way. So it will become. The velocity in that direction will be v minus u prime. Velocity in that direction after bending. Correct? So it will become 2v minus u prime. Now, something is not yet right. I am making a mistake here. I did this. Pardon? It should add. Let's do it slowly again. Let me start again. I am having a velocity u going in this direction, and that's velocity v. And the velocity is u minus v in this direction, which in the planet's frame I will call that
So one is approaching from backward and other is approaching forward. Is it? One side two diagrams are different.
No, u is greater than v. So from the planet frame, that's that. So it will come with u minus v from this side. And then it will turn and it will go in that direction, and that will be u minus v in that direction. So when I add the two, this will just add up to minus u in that direction, u minus in that direction. So u in that direction is, I have to add that, so it will start moving with u in that direction. Okay? That's what happens. Here it will move through u. You can do the thing slowly and get this result. It is actually very similar to a truck moving with a velocity u and a ball moving with a velocity v. Let's firstly go to the rest frame of the truck. In this, the velocity of the ball, as I am moving in this direction, velocity of the ball will be v plus u. Right? In the rest frame, after collision, the velocity of the ball will be v plus u in the opposite direction. Right? This is before collision. Before collision. and this is after. In the rest frame of torque. Now let me go back to the frame in which the torque is having a velocity v. In the rest frame of roll, this is rest frame of roll. So again, rest frame of roll. After collision, the velocity will become v plus.
This is the velocity will remain same.
Right?
Velocity will remain same on
In the rest frame of the torque. Only in the rest frame of the torque, if I am assuming the torque, pardon?
after the collision.
After collision, the speed will remain the same. Velocity will just, for example, if I throw a ball at the wall with a speed v, it is going to rebound with a speed v in the opposite direction. Right? Energy, the wall does not absorb much
Right,
energy.
assuming that what is not observing and is not what taking any energy from the rest.
Yes. In fact, if you do a full calculation, I will just mention this, maybe we can do this again. If I take a mass m colliding with another mass m, and if I look at it, m by m, when it tends to 0, one can show the energy of after collision, energy of this remains with itself, but on the other hand, this absorbs momentum. When it collides, the momentum of this ball goes in the opposite direction. So it means the momentum is not conserved. If I throw a ball at the wall, the ball comes back with the opposite velocity. So momentum is absorbed by the wall, but the energy is not absorbed by the walls because the energy remains the same. In this limit, m by m going to 0, energy remains, energy absorbed by, taken by n. Okay. One can show this, but momentum is taken by n. Otherwise, this ball cannot change momentum which it has. So here, notice the ball after collision goes away. Incidentally, there is a very nice demonstration of this, and the demonstration of this exactly. You take a football and put a tennis ball on top of it.
Take a baseball,
Or anything. You drop it. When you drop it, this ball is going to hit down. Both of them are coming down. This ball will hit with the velocity v, and assuming elastic collision, it will move with the velocity v up. This one is also coming with a velocity v, but this being very much lighter will now move with a velocity 3v. That will be the corresponding case with u and v being equal. So you will see the ball shoot up very, very much. You take a, as you say, a baseball and put some on top of it a lighter ball, basketball, and take a lighter ball and do this. So very nice experiment. We can try. The other thing I want to tell you is, yesterday I had mentioned about looking at net and look up things. I want to give you, before I start my lecture proper, I want to give you a small thing which I picked up from the net, and here is a small demonstration of that. And the analysis of this is very interesting. I will just go away. Here is a heavy mass, and here I have a very light mass. Okay. Whatever you can see, because I want to show it with that, or maybe I can try to do it here. Notice, if I leave it, it touches the ground, right? I put it here, and I have not changed the height of this. It is at the same height. I have not changed the height of this, and I am going to leave this. It did not touch the ground. Okay. An analysis of this is very interesting. It's a very simple experiment, and you can. Fine.
Shall I give a?
Yes.
When the keys are falling down, they generate a centripetal force on this lightweight body. and that goes in uniform circular motion, and there is I omega conservation, and omega goes on increasing as the I goes on decreasing, and there is a friction generated.
No,
in the
friction
plate
is actually not relevant. Neither the friction nor the radius of this is relevant.
Yeah.
You can write the equation and analyze it. It turns out that equation cannot be solved in ordinary, just analytically. You will have to do it numerically. But then you can model this in some approximations in certain limits. And I have the relevant papers with me. So if you are interested, you can take a photocopy of those. And perhaps some of you might like to read them and present it during which is possible. So this is something which is slightly counterintuitive. One would not have expected, one would have just expected this heavy mass to fall down, but that isn't it. So I'm just giving you an example of how one can pick up things by looking at the net and seeing things. So now let's get to my topic. Yesterday we had discussed a single particle, motion of a single particle under a central force. Here, today I am going to talk about system of particles. And what is the final answer that we are going to get in this case is that the motion, if it is described above, motion is broken up into two parts, motion of the center of mass and motion above the center of mass, then things become simple. If you do not do that, you try to do it through an arbitrary point, you can make mistakes, and there are many things which you have to add if you want to do it accurately. So the final message is the use of center of mass is very important, and any system of particles, best analysis is done from the center of mass and about the center of mass. So let's go over that now. So I have system of particles. We have n particles. Mass is m1 to mn. Position vectors are r1 vector. These are the vectors which Professor Kuda refers to, except my space is that of R3, the three-dimensional space, with all the scalars that I will write are real numbers and not complex numbers. Then they are subject to external forces. Each of them may be charged in an electric field, they are moving in a magnetic field, and so on, which is Fy. So the force Mi in an inertial frame again is Fi external plus summation I not equal to j, summation is over j going from 1 to n, F I. Fij are the forces exerted on the ith particle by j. Okay? And there is an external force on the ith particle. Now I can, of course, this start I 1 to n, Mi, Ri, equal summation Fi external I 1 to n plus I 1 to n. So now let me look at this term. Let's say, let me look at f I equal to 1 and 2. Let me just concentrate on that. So I will get when I equal to 1, j will be 2. This term. Next term will be F 2, 1. This corresponds to I equal to 1, J equal to 2. And of course, I is not equal to J. And similarly, when I is 2, J can take 1. So this is the expression. The force exerted on 2 by 1 and the force exerted by 1 on 2 is from Newton's third law. So all these terms that I have here cancel out completely, and I am left with this expression. This is the total force acting. Now I will define my center of mass, no problem, as if I write summation mi as n, then I write out here as m I ri as m r center of mass. Then I get m r I dot is equal to m r center of mass dot or m I double dot is equal to m r center of mass. I will also write a couple of more equations. Ri, any vector, I can write it as r center of mass plus r I dash. That is, here is my set of particles and my center of mass is there. So this is r center of mass vector. This is my ri vector to the particle. This is and this is this is my origin from where I am taking my measurements. So if I substitute that here in this equation, immediately I get summation mi r center of mass plus summation mi ri prime equal to m r center of mass, and of course these two cancel, and I get the result summation mi r I prime equal to 0. I can differentiate this and I will get mi r I prime dot equal to 0 similarly. And my sum is all from 1 to n. Summation r I double dot. Is there any questions so far? Is it? So the first result immediately follows, and the first result is that if I use this equation, this is the total force acting on the system of L particles, whereas this expression I have here is nothing but, if I differentiate this, that gives me m. This is my first result. I'm sure all of you know summation I f. So the motion of the center of mass is governed by all the forces acting on the various different particles. So it's as if the center of mass sees all the force at its place. And this, the most famous example of this is to take any body like this. Here it's a system of particles. If you try to trace the motion of any particle, if I throw it, it's going to be very complicated. It will rotate. On the other hand, if I put a mark at the center of mass will follow the path of a parabola. Because all the g which is acting is just can be thought of as acting at the center of mass, and the motion of the center of mass is described in a very simple way. And I'm sure if you take a cardboard and mark it and throw it, the parabola path can be very clearly visible. That's the standard. Now let's proceed further. So, is there any thing that this I'm sure all of you are familiar with, so there is nothing new about this. Now, let me get to the next point, that is the angular momentum. One more point here, I can talk in terms of momentum of the system. Total momentum of the system, P, is summation mi Ri dot, which is equal to summation mi R center of mass dot plus Ri, which is equal to m R center of mass dot plus mi Ri prime dot. But mi Ri prime dot is 0, so this term is 0, and I have only this expression. So this expression which I have is nothing but the momentum about the center of mass. So the total momentum can always be thought of as the momentum about the center of mass. And this equation can be written as Vp center of mass, Vp, which is the total momentum of the system, is summation over I, all the forces acting. So much for momentum. This is the momentum. Now let's go to angular. So we know how to define angular momentum. The system L is given by summation mi Ri cos. It is R cross P, summation of Ri cross mi Ri dot is the momentum of the ith particle. So this is the momentum. Now I am going to rewrite this as summation I 1 to n mi times R center of mass plus R I prime R center of mass dot plus R. So this is nothing but, first term, I can write down R center of mass outside, cross R center of mass. This is M, so this is R center of mass. Plus, next term will be summation mi Ri prime cross R center of mass plus, I have forgotten one more term, plus mi R center of mass cross R. This term is again 0 because R center of mass dot does not depend upon I. So I have mi Ri prime, but mi Ri prime is 0. So this term is 0. Similarly, this R center of mass can be taken outside. I get mi Ri dot prime and mi Ri dot prime is 0. So this term is also 0. So I am left with the final answer, R center of mass cos P center of mass mi Ri prime cos R. This is what I will call the angular momentum associated with the center of mass. this one is the angular momentum associated about the center of mass. About the center of the system. Now let's write down dl dt. This is dl center of mass dt plus dl about the center of mass. Let's look at each term. The first term is dl center of mass dt is dr center of mass dt. I have to differentiate both of them. Cross d center of mass plus r center of mass. This term is 0 because P center of mass, this is apart from the mass m, is the same as the velocity of the center of mass. P center of mass is d, I have written down here, whereas my P center of mass is here, mi r center of mass, so this is 0. Whereas dp center of mass is nothing but the external force, as if it is acting at the center of mass. So this is nothing but r center of mass cos theta. I will write that as the total external force, as if it is acting at the center of mass. That's the first thing.
So can you repeat this point?
Pardon?
Why it is 0?
Why is this 0? Okay. What is P center of mass? P center of mass is here. M R center of mass dot. So this is R center of mass dot cross R center of mass dot. So it is the same vector. Now let's look at the next term. Next term is here. So I have to differentiate this term, that is ddt of sum of mi or I prime. This is my second term. Let's call this 1 and call this 2. So this is my 1 and that is 2 I cross the first term again is 0 because I differentiate this, I get the same thing. So I need to keep only the differentiation of the second term, which is mi ri prime cross r prime. Here, I can rewrite this as mi ri prime plus r I. Why? What is the difference between these two? The difference between these two is only r. Where have I have brought something. R I have here. Okay. The difference between these two is r center of mass double dot. If I remove the r center of mass double dot, I will just get mi ri prime, but mi ri prime is 0. That is, maybe I should write one more step to indicate that. So this can be written as mi ri prime. I add r center of mass plus ri prime and write the double dot. This term will just give me mi ri prime, but mi ri prime is 0, so this will not matter. Right? I can just add that. So this becomes equal to mi ri prime cross r double dot, but ri, yes, this is clear from here to here, because all I did was I added r center of mass plus r prime. So when I do this, this term is just 0, as mi ri prime cross r center of mass, but mi ri prime is 0, which I have all those equations here. Yeah, please ask. Which step? That's a double dot. Okay. Instead of double dot, maybe I'll just write here. Please write. Please say it again. Oh, here. Prime. That was fine. Anyway, whether that's defined expression. But what is mi ri dot? That is nothing but summation I r I prime cross the force acting on the ith particle. What is the force acting on the ith particle? It is Fi plus J not equal to I. This is the Fi external. J not equal to I. F I J is the force acting. Which I write it as summation I r I prime
So
cross.
you are replacing what Ri prime.
Yes, please.
See, Ri is equal to Rcm plus Ri prime, am I right?
R vector.
R vector.
Here is Ri is RCM plus Ri prime.
Okay. Just see the second step, no?
That
From here to here,
Now, next
RCM
summation of
plus
Mi, Ri prime.
Ri prime,
Then?
and this is double dot.
so
In the double dot, I have added R center of mass to Ri prime.
prime, RI prime,
Why?
prime,
Why? Okay. Let me see why. This, by the way, if I didn't have this term, it is exactly the same as the
Yeah.
earlier equation.
Yeah.
Correct? Supposing I had not added this term. If I didn't add this term, this is Ri prime double dot, and I have written it as d squared dt squared Ri prime. I have added an extra term. This extra term I claim is 0. Why is it 0? Let's look at this extra term. This extra term is summation mi ri prime cross d squared dt squared times r center of mass. Right? Is that okay? Who asked this? Is it okay till now? But this can be pulled outside the summation.